Yes, so our second question today is on vectors. This question tested on KCSE 2000 in the year 1986. 1986. So it's a 10 marks question. Let's see. So in the diagram below, OABC. OABC is a parallelogram where vector OA is vector A and AB is vector B. Then N is a point on ON such that ON is to NA is equals to 1:2. 1:2. So N is there. That's N. This 1, this is 2. Then you're told it's a parallelogram. Properties of a parallelogram. Opposite sides are equal and parallel. Opposite sides are equal and parallel. So therefore, opposite sides are equal and parallel. Then you're told, then you can see the line CA. Join that line CA and line BN. Line BN. Join them there. And then there is line OX from O to point X there. That's point X. So you have CA, you have BN, and then point OX. You are meeting at point X. You are told find in terms of A and B, in terms of vectors A and B, 1 vector AC, and 2 vector BN. So we first of all do that. AC and vector BN. We first of all do those two. We find that. So because this one is a parallelogram here. Properties. Opposite sides are equal and parallel. If OA is vector A, even CB is vector A also. That is vector A. If AB is vector B, even OC is vector B. The direction is O to C, and then this is A to B. So that direction is positive. So this is B and this B. Vector B. This is A and this side is A. Because of the properties of a parallelogram. Then you are given that N is a point on OA, such that ON is to NA 1:2. Because 1:2. So therefore, this is 1, this AN, O to N, that's 1, N to A, that is 2. Therefore, you want to find the values of the vectors AC, vector AC, but in terms of vector A and B only. And then BN. We start with the first one, first question. AC. So A is the starting point. Our A is the starting point here, in this case, from A to C. The easiest route, you can use AB, BC, or AO plus or C, any of the two will lead us to the correct answer because we want to move from A to C. So let's use AO plus OC. If you use AO, OA vector OA was A. Therefore, AO, the direction changes. It becomes minus A. So it becomes minus A because of the direction. So therefore, our AC now is AO, that is minus A, plus OC, where our OC is vector B. So this becomes B minus vector A. So therefore, our AC, vector AC, is B minus A now. Why is it B minus A? Because this direction has changed from OA to AB. The direction has changed. That direction has changed. So that is AC. That's AC. That's AC. And we agree with that. That's the first one. Then we go to BN. Go to BN. B to N. B to N. You can use the easiest route. And the easiest route here is BA plus AN. BA plus AN. So BA direction changes from AB now to BA. So therefore the direction is changing to, this is minus B. That's minus B. What about A to N? A to N, again, the direction is changing. Because this was OA, so it is now along AN. So this becomes, because the direction has changed, minus 2. 2 plus 1 is 3. That is 2 minus 2 over 3 of OA. It becomes minus of OA in this case, because the direction has changed. Or you take 2 over 3 of minus A. So therefore, in this case, you get minus B minus 2 over 3 of A. Because the direction here has changed. The direction has changed from OA to AO, towards AO. So therefore, it is 2 over 3 of minus A. That's why we're getting this one as minus. So that is our second value. So that's the second question there. Yeah, now part B of that question. Part B of that question, KCSE 2, 1986. You are given that there is AC, you can see from the diagram, AC at the BN intersect at point X. And you're given that AX, our AX, is equal to HAC. HAC, vector AC. And BX is equal to KBN. KBN, that's vector BN. So the examiner is telling you, Roman 1, by expressing OX in two ways, by expressing OX in two ways. By expressing OX in two ways, find the values of H and K. Find H and K. Find H and K. And then from there, you express OX in terms of vector A and B only. So let's see. Let's work it out now. That's part B. So we are told AX, our AX now, from A to X. Our AX is equal to HA, AX equal to HAC. So therefore, this H there, meaning H is a fraction. That AX, because this is X. AX is a fraction of AC. So therefore, say AX is equal to H. What is our AC? We had our AC somewhere. Our AC is this one. B minus A. B minus vector A. B minus A. So open this bracket here. You get H vector A minus H vector B minus H vector A. That is our AX. That's another step. You work out that. That's AX. That's AX. Then we are doing this. Go to BX. What's our BX? What is our BX now? Our BX was BX. Check the diagram. BX is equal to KBN. So this is K. KBN. Therefore, meaning K or BX is a fraction of BN. So therefore, K BN. Where is your BN? BN, we had it here. Minus B minus 2 over 3 of A. Minus that one. So you work out that. Minus that. Minus that one. So you already have that. You already have that one. So then the next step, open this bracket. You get K minus K vector B minus 2 over 3 K vector A minus 2 over 3 K vector A. Because once you open the bracket, you get minus K vector B minus 2 over 3 K vector A. That is vector BX. The one that you are told to use here. The one that you're told to use. So examiner is saying by expressing OX in two ways. Here there is no OX. There is no OX. From O to X in two ways. So you must keep the diagram. So OX in two ways. One OX must pass through this AX given. And the second one must pass through our BX. So we are doing this one now. We can have this. Now we can have now the diagram with us. We see. You want your OX. Let's call it 1. The first OX must pass through AX. Now AX to connect. So let's see. OX passing through AX. It is OA plus AX. Is OA plus A. It is OA plus AX, where our OA is vector A, and our AX, we already have this one, H vector B minus H vector A. A plus H vector B plus H vector A, because it is OA plus AX. That's what to do in that kind of question. That's how to work it out. Then from there, what do? You bring the right terms together. And in this case, the right terms are the vectors. The vectors are the ones that are right terms. So here you check vector A and vector A. You say A minus H vector A plus H vector B plus H vector B. So therefore, vector A is common, factorize, you put it outside there. Then this becomes 1 minus H, because you are factorized, plus H vector B. And this is your OX1. That is your OX1. This is your OX1. That's your OX1. So that's what you get. Your OX1. Your OX1. Then from there, you find your OX2. You express your OX2. Express your OX2 now. Express your OX2. Passing through BX, OX2. OX2 there. So OX2 must pass through BX. Must pass through BX. It must pass through BX, this one. When your OX, to pass through BX, you can use OA plus AB plus BX. It is OA plus AB plus BX. You can use that route. Or even use OC plus CB plus BX, provided you finish with BX. You end with X here. Must be BX. These two values are the same. OA plus AB, they are the same. You get even if you use this other route. You get that. Then plus BX. So therefore, take OA. Take your OA, which is vector A, plus AB, which is vector B. Then from there, BX. What's our BX? Minus K vector B minus 2 over 3K vector A. Minus K vector A. Minus K vector A. Now, so the next step remaining is to bring them, the right terms, together. And I repeat for OX2. OX2 must pass through this BX. So it is OA plus AB plus BX. You must use a route that you must at any given time pass through BX. So it is OA plus AB plus BX. You can have that. So you can have that one. So now we can love this. We can have that. So that we can solve all the whole equation here now. We can use this space to solve now this equation here. You have OX1, now OX2. But OX2 not yet simplified. Let's simplify. Let's come together. Check vector A here, and vector A, minus 2 over 3K. A, bring them together, A. So OX2 there will be vector A minus 2 over 3K vector A plus B minus K vector B. That is OX2. You are now bringing the terms together. So that once you bring the right terms together, you factorize. Once you bring them, you factorize. So therefore, in this case, factorize A. A is common. 1 minus 2 over 3K plus B is common. 1 minus K. 1 minus K. And these are vectors. You factorize A to bracket 1 minus 2 over 3. K, that's vector A plus vector B to bracket 1 minus K. You already have the two values, the two vectors. Vector 1, OX1, and OX2. So what do you do in that question? When you have the two vectors, you are supposed to equate them. You equate the two vectors, OX1 equals to OX2. OX1 equals to OX2. So you say OX1 is equal to OX2. Equate their values. So take this vector OX1, which is vector A in bracket 1 minus H plus H vector B is equal to OX2, which is vector A in bracket 1 minus 2 over 3K plus vector B 1 minus K minus 1 minus K. You have that. So you have that one. So that's the question there. Answer question. Answer question. Equate vectors are the rectangles. So in this case, the two sides, vector OX1 and OX2 there. So equate the vector A and vector A on this side. This one is equal to this. So therefore you say 1 minus H is equal to 1 minus 2 over 3K. That one there. We shall form an equation from there. Let's first of all equate them. So 1 minus H is equal to 1 minus 2 over 3K because there's vector A, vector A. We go to vector B. This is vector B on this side. Then vector B. So you say H is equal to 1 minus K. 1 minus K then. 1 minus K. Now, H is equal to 1 minus K. We have this one, this one here, and then 1 minus H equals to 1 minus 2 over 3K. So I want us to multiply this. Bring this one on this side. 1 minus H is equal to 1 minus 2 over 3K. You can bring this on this side and then take this on this side. If you bring this one on this side, you subtract 1 minus 1, you get 0. Is equals to, and you take this on this side, you get H minus 2 over 3K. You are getting something like that. And here you had H is equal to 1 minus K. So you can take this on this side. You say 2 over 3K to make it positive is equal to H. Is equal to H. So for you to find the value of K, you can use substitution or even elimination. But because it is just H is equal to 1 minus K, why don't we substitute? Substitute. Substitute. So to substitute this one, you take H is equal to 1 minus K. You get 2 over 3K is equal to H. Our H is 1 minus K. So you bring right terms together. Bring this one here. You get K plus 2 over 3K equals 1. Here you get 1, 2 over 3K equals 1. So find K. Convert this one in improper fraction. You get 5 over 3 K equals 1. Therefore, to get K, you can multiply both sides by very simple law of 3 over 5 times 3 over 5. So that this cancels this. You get 1 times 3 over 5, you get that is 3 over 5. That is K. That is K. That's K. So the value of K is 3 over 5. The value of K is equal to 3 over 5. So therefore, to finish that question here, now we can find H. Our H was 1 minus K. Our H was 1 minus K. And you already have K. K is 3 over 5. You substitute. So H is equal to 1 minus 3 over 5. So H is equal to 2 over 5. And you subtract that. You get that H is equal to 2 over 5. And that's our KCSE question, 1996, paper 1. So you can see it's a 10 marks question. It's a 10 marks question. So you work it out like that. So you get that K is equal to 3 over 5 and H is equal to 2 over 5. So there was the last part that the examiner had said, express OX in terms of A and B only. In terms of vectors OX in terms of A and B only. What do? You take one of these equations. Take one of these equations. You can take like this one, the one that we already have here. You can take like this equation here. We are want to express OX in terms of vector A and B only. This was OX. That OX is equal to A, vector A, 1 minus 2 over 3. What is k? You need to substitute. Our k is 3 over 5. 1 minus 2 over 3. 2 over 3 times k is 3 over 5. Because you have this is k. 1 minus 2 over 3 k. 2 over 3 k. And k, we have k plus vector b to bracket 1 minus k. Which k? This one. You take in any of the two equations. Take any, substitute the value of k or even the value of h. In this case, we are substituting k, 1 minus 3 over 5. And we have substituted this one. The value here, 2 over 3 k, 2 over 3 times 3 over 5. And this is 1 minus 2 over 3. 2 over 3 there. So therefore, what do you get? Our OX now, our value of OX. This one will be, so our OX in this case will be, OX is equals to A, vector A, 1 minus 2 over 5, plus 3, this is 2 over, this now becomes what? Becomes 2 over 3, 2 over 5, 2 over 5 of B. And this one you can also simplify. 1 minus 2 over 5, that becomes 3 over 5. So your OX, what does to finish there? Our OX there. Our value of OX is equals to 1 minus 2 over 3, 2 over 5. You get that is 3 all over 5 of vector A plus 2 over 5 of vector B. 3 over 5 of vector A plus 2 over 5 of vector B. And that's how to deal with that question. That is KCSE 1996. That was KCSE 1996. So that is how to solve that question. And that is vectors. And that is the end there. The end of that question. So therefore, you must know how to find the equation. You must know how to find the equation there. How do you form the equations? How do you deal with those vectors? Then after that, apply them. Then get the values of h and k. Then you substitute and get the correct answer. So asante sana. Thank you very much.